Hi, this is Shannon Seaver. Today we're looking at section 6.4. The main emphasis of this section is ratios, proportions, and variation. This is part 1. So we're going to solve proportions today, and we're going to solve problems using proportions. So we have a couple definitions we need to go through before we go any further. First one is, what is a ratio? A ratio compares quantities by division. So for instance, one ratio might be 12 inches to 1 foot. So, or we could say 1 yard to 3 feet. A ratio is simply a fraction. It could be just like 3/4. A proportion. A proportion is a statement that says two ratios are equal. You know you have a ratio when you have something like this. Whenever you have an equal sign in between them, that is a proportion. Notice that I'm not adding or subtracting anything from either side. It's just 3/4 equals 9/12. Cross product, principle for proportions. In this particular case, if I have A over B equals C over D, just like I have over here, say I have 3/4 equals 9/12. It says that if I take AD and multiply them, then BC multiplied together will equal it. So let's try that. 3 times 12 equals 4 times 9. Well, 3 times 12 is 36, and 4 times 9 is 36. So that checks true for this particular proportion. We use that a lot in trying to solve for a variable that is in the proportion somewhere. So let's look at an example of that. We have a variable here of x. We don't know what it is, but we're going to use the cross product to find it. So we can take 10 times 3 and have that equal to 2 times x. Well, 10 times 3 is 30, and I can solve that by dividing both sides by 2. So I now have 15 equals x. You can check your work by putting it into the equation up above, and you'll find that it actually does end up being the same. So now let's try it for this one. This one's a little bit more complicated because we have this whole thing here. So if I take 2 times 910 minus x, and that is going to be equal to 11 times x here. So here I have a binomial, and I'm going to need to distribute this 2 to both. So 2 times 910 is going to be 1820 minus 2x equals 11x. We're not done yet because we need to get all of our variables to one side. So I'm going to add 2x to both sides. And now I have 13x equals 1820. We need to now divide both sides by 13. So let's check that on our calculator. We have 1820 divided by 13, and I have x equals 140. That is our answer for this one. So now I want you to pause the video, take some time, and try both of these problems, and then come back and check your answers. Hopefully you've got some answers now, so I'm going to show you what I got. Here we are. We have x equals 45 for the first one, and x equals 30 for the second one. All right, so now let's look at an application problem. Here, the property tax on a house with an assessed value of $45,000 is $600. Determine the property tax on a house with an assessed value of $112,000. So I'm going to put property value over tax on both of these. So here I have $45,000, and the tax for that was $600. The second one, we don't know what the tax is. We're trying to find that, so I'm going to put X here for that. And I know that my assessed value for that particular house is $112,000. So I'm going to use my cross product rule to solve for this. So 600 times $112,000 equals 45,000 times X. 600 times $112,000 is 67200,000. So 67,200,000. Now I want to divide that by 45,000. I get 1493.33. So $1,400 and $1,493.33. All right, I want you to try the same problem. Take a moment, pause the video, and come back and check your work. Hopefully you got $2,284.62. Now, there's another application that you're going to run into in this section called Capture-recapture. Here, let's read through this problem, and I'm going to show you how to set it up. So, wildlife biologists catch, tag, and then release 120 deer in a wildlife refuge. So the first amount of deer that they catch was 120. 2 weeks later, they observe a sample of 140, and then 25 of those were tagged the first time. Assuming the ratio of the tagged deer in the sample holds for all deer in the refuge, approximately how many deer are in the refuge? So we are looking for this. We don't know how many total deer are in the refuge, but we do know the original amount of tagged animals. We know the total number that were captured 2 weeks later, and of those, we know how many had tags on them. So we're going to replace the original number, which was 120. We don't know X. And we know that the number of recaptured tagged animals was 25. And the total number of the sample in 2 weeks later was 150. Now that we have this set up, we can actually cross multiply and divide. So I'm going to take 120 times 150 equals 25 times X. So 120 times 150 is 18,000. And then we'll divide that by 25. So we have a total population of deer in this particular refuge is 720. That's an approximation, and it's probably a pretty good approximation. So now I want you to pause and try the same type of application for this. Did you get 725? That's what I got. So if you guys have any questions over any of the things that we've gone over today, please bring them to class tomorrow. Thank you.